to think about a problem. Whenever you're seeing a problem, you're looking for options. Yeah, sir, please.
Okay, one.
Yes.
Yeah, I will introduce you, Miss. Yeah, good morning, everyone.
Good morning, sir.
Yeah. Republic Day greetings to all. Hearty welcome to the online problem solving session series organized by Math Aspirants groups. Today we have the second session in the multivariable calculus by Mr. Abhirup Das. Abhirup is currently pursuing PhD at TCG Crest, Kolkata. Without much delay, I welcome everyone to this program and welcome Abhirup to handle the session. Welcome, Abhirup.
Yeah, okay. I'm Abhirup. I'm doing my PhD in TCG Crest, Kolkata. This is a relatively new institute. You can try and Google it. TCG Crest, Kolkata. I'm working there in PhD. I'm doing my PhD in algebraic geometry. So I'm associated to an academy named LS2M, Let's Study School of Mathematics. We prepare for various mathematics, data science, and M.Tech courses. That's what we do. And we try to train students not in the not in a way which is very much in vogue, but rather in a way which is classical, I would say. That okay, you will have to have the problem solving skills. Uh, you will have to pick up the speed to solve MCQs. All is needed, but you will have to understand that first you will have to learn mathematics, and then the last minute preparation for the say 2 months, 3 months, you can just and then think about picking up speed. Actually, whenever I keep giving this analogy, suppose we are playing cricket. We have just started playing cricket. So first we just play cricket. We play our shots, work on our defense. We don't think about think much about short ball and all that. What we think about is go to the nets, bat every single day. That's it. Now, suppose you are going to South Africa, you are going to England, you are going to Australia. Then, before the tour starts, after 2 or 3 months, you go there, you play the first class cricket and get habituated to the conditions there. That's the way to do it. I mean, not the other way around. Okay, so without much delay, let's start our sessions. So, I believe I had given 2 or 3 homeworks last day. So, let's start with that. Let me see. Let me share my screen first. Just give me a moment. Yeah. Actually, I had an infection in my throat infection actually. So it was really on and off. So I wasn't really sure if I can take the class. But then again, I mean, I talked to sir and he said, oh, no matter. Okay, let's do it. So can you see my screen?
No, I think you are
Not yet,
not
Abhirup.
going to in the presenting mode.
Yeah,
Yes, it is now.
Oh.
Is it?
right.
So these were our problems. Okay, the last day.
Yes.
We will start with the last example. Okay. Lot of these problems are selected from JAM. What I couldn't do is that, I mean, right beside every problem, the corresponding year. I did not have the time. I was away in IIT Madras, then came back and then had this serious physical condition. Supratim, you were in the class, but I think there were a few others in the class as well. Who were they? I just forgot their name. Do you remember?
Yes. I think I don't recall their name, but if they are joining here, I would recognize.
Yeah, I also I forgot their names.
And some student are constant. They are invariant in on class. Good. They are saying there.
Yeah, but they were, I mean, responding very much. Okay, let's try. So you see what the last problem I gave was an example. What was this example? So you see the approach, what we do here. Hmm. Tell me, can it be surjective? If can never be surjective, right?
Yes, it's because R is lack of I, which is extra complex.
Because
Because it lacks of the imaginary unit I.
so what? This particular problem is not from Jam, but I talking to you, I thought maybe we could talk about it. See, S1 is compact, so its image is supposed to be compact as well. So if S1 cannot be R because R is not compact. After this problem, I mean, we will go to this type of problems. So where we will see that indeed these are maps. Actually, I have made a small mistake today. I forgot to share this link in my own group. That's why I believe the attendance is a little bit low. Because of my illness, I'm forgetting a lot of stuffs. Okay, so this is one.
চিত্রাল খেতে হবে, এটা খেতে হবে।
And what about injectivity? For injectivity, you see, so if S1 to R is injective, then take and suppose F inverse 0 is, say, a point P belongs to C1. S1. See, this is singleton. The pre-image is singleton because S1 is injective, right? So, if restricted to S1 minus P, right? Right? I have restricted the continuous function to a subset of the domain. So it is supposed to be continuous. Okay, let's refine the logic a little bit. Is continuous, then if S1, after this problem, we will move on to the jam related problems like this. Example 7 and 8 is connected, that is if S1 is an interval in R. So let if S1, okay. So if is injective, then take 0 belongs to R, and suppose that if inverse 0 is, so the pre-image is a singleton because f is injective, right? Not exactly 0. Take C belongs to A comma B inside that domain. Okay, I'm choosing a point inside A comma B open. Continuous as well as surjective, right? Because you see, the image was closed bounded AB. We have just removed one point and restricted F to this subset of S1. So it is of course surjective. Now you see which there is a contradiction. Why? Since S1 minus P, which is nothing but the circle, minus say this point P, is connected, but is not. I think Supratim mentioned in the last class that R is an ordered field. You see, that is again the case. If you move one point from an ordered field, it becomes disconnected.
Yes, yes.
That's the property. Okay, let's try to solve this problem. Example 7 and 8. First example 7. So f is a function from x not equal to 0. So I should write x axis, right?
Yes, sir.
No, sorry, y axis. No. Hmm. X equal to 0 is y axis. The function is sending x comma y to tan inverse y comma x. So let me first see. Multivariate analysis is the first thing in geometry, if you say. So I'd love to draw these pictures. Supratim, you are in that group, Math Aspirant 3 or something?
I was included in the jam group and the net group, I think aspirant 4.
Okay, okay, okay. That's why you didn't just couldn't connect to me.
Yes, yes.
Hmm.
Please.
But you can ask to sir for my number. It is not a big deal.
Okay, I am thinking of that in the last session of today's class.
So yeah, what was that? Yeah. Okay, Supratim, what is your first intuition? I'm asking Supratim because he was in the last class and he communicated to me, so I remember his name actually. So I mean, I would love if anyone else joins the discussion. Hmm. What do your first intuition is?
Uh, what was the question exactly? This is continuous or
Is it continuous? Is it continuous?
okay. I'm continuous on zero or what?
I'm
Okay.
saying talking about the whole thing.
Hmm. I think not at zero zero because if we
No, 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 no.
approach
0, 0 is not there. We have removed the x-axis. Sorry, remove the y-axis. So 0, 0 is already not there.
if we approach along x-axis and y is equal to x-axis,
Uh-huh.
then it is one thing it is uh, 0 and otherwise it is pi by 4, I think, and two are different.
Yeah. With that logic, we will move on. I mean, we will carry on. Okay, so you see the problem. If you take xn in here, I mean, if you are considering xn to be in this region, okay, so xn is a sequence here. So x1, x2, you are, I mean, you are approaching -1, 0 from this region. What should I call it? Call it 1. And call this section 2. So there you have a sequence y1, y2, they're approaching from there. Okay. So xn is a sequence in 1. 1 is this arc. Okay. This arc. This one. This arc. Yn is a sequence in 2 with limit xn n tends to infinity equals to limit okay. Now see what happens. You see xn here, I mean maybe there is a slight problem, because not a slight problem in notation, I believe. I should have written, wait a minute, xn yn xn prime yn prime. I think this is good. The sequence here is xn prime yn prime, and the sequence here is, in this part we have xn ym. Okay. Okay. So now when you try to compute tan inverse yn by xn, or maybe I should write like this. You see yn by xn is negative, right? Where again yn prime by xn prime is positive, isn't it? Because
Yes.
yn prime and xn prime are both negative. They are in the third quadrant. So the ratio is positive. And for yn xn, one is positive, another is negative. So the ratio is negative. So once you put tan inverse yn by xn, what do you get? I mean, take the value inside just minus pi by 2 to pi by 2, right? So if you are approaching from negative, what do you get? You go to minus pi by 2, right? I mean, xn by yn, you see, I mean, xn. Sorry, yn by xn, it is going to minus pi by 2, right? Whereas tan inverse yn prime by xn prime is going to pi by 2. Clear? Is that clear?
I think it is minus pi by 2 or pi.
What is the problem?
Mm, Tan inverse yn by xn equal to minus pi by 2. How here we are want to reach minus 1 comma 0 along this arc in the second quadrant. So uh, I think it is pi.
Oh, you are saying it's pi and minus pi, right?
No, but it is domain is restricted to minus pi by range is restricted to minus pi by 2 to pi by 2. So
Uh-huh.
pi.
Okay, so if I remove the range, then you tell me what is the logic.
I think it is one thing is minus pi and other thing is pi.
Hmm. Correct. Sorry. I mean, it has the period 2 pi. So that's what it should happen. Sorry. I'm messing a lot of
To
things up.
sequential.
Uh, couldn't hear you.
So you're using sequential
Yeah.
limits to prove that it is discontinuous. But we can also take
Hmm.
another approach that it is tan inverse y by x. So we can put the function as theta. So tan theta will be equal to y by x. Tan theta is the slope. So
Hmm.
when we take a point 0 comma 0 from the left hand limit,
Hmm.
uh,
Hmm.
we go to y by x, which will be is y by x goes to 0. That will be negative. From the left hand side, it will go to negative infinity, and from the right hand side, it will go to positive infinity. And because tan inverse is bounded, so it will jump from pi by 2 to negative pi by 2.
What are you saying? So tan inverse y by x is basically theta. Then
Tan theta is the slope, so means we
hmm. Sushti, you are not audible.
and then we take y is equal to mx, and then we get that tan inverse of
Hmm.
m is equal to theta. So then it will take different values for different m's, so it will be discontinuous that way.
Hmm. Sorry. I couldn't get it. Y equals to mx. You are putting it. Okay. No, I mean, first of all, you have to see where we are checking the continuity. When you say y equals to mx, you are taking a line that passes through the origin. So that way you can say the function is not continuous at the origin. But see our domain. We have removed the y-axis already. So 0 0 is not in the domain. And to see that
Okay, so
f is
then
not
we can
continuous at 0 0. Hmm. Yeah, go ahead.
take y by x means at x tends to means the right hand limit will go to plus infinity and the left hand limit will go to minus infinity. And because our function is bounded in negative infinity and positive infinity, it will jump from pi by 2 to negative pi by 2.
So you are taking y by x, and what is your point? At which point you are taking the negative, taking the limit?
X tends to 0, sir.
X tends to 0. Then, and what is 1?
Right hand limit.
What is y? And what is y? You are checking the continuity at a point, right? So what is the point?
Zero comma 0.
Again, 0 comma 0 is not in the domain. I have removed the y-axis.
Okay, sir. Maybe then only
No,
sequential limits is the
then
right approach.
probably we will have to come up with some other point actually to look at your approach. Okay. So the next problem is a similar problem. Hmm. Hmm. Yeah. Then, Supratim, can you tell me which point should I look at?
Yes, I'm thinking.
Because the approach will be same. You understand, na?
Yes, I think it should line y-axis
Hmm.
0 comma 1 and 0 comma minus 1.
So again, we can take a sequence here and a sequence there. So call it xn, yn, and it is xn prime, yn prime, right? Oh, miss the problem. This is root over x and y, sorry. So let's try to see, let's try to find out a region where it is continuous on, right? Because you see root over x comma minus y, it is not defined everywhere, na? So it will be defined x by y only in the first and the second quadrant, right? Sorry, and the third quadrant, right? Because the thing inside root over has to be positive, right?
Yes.
Hmm. But you see, this will only be continuous on A union B, where A is so. Can you tell me where it is not, why it is not continuous anywhere else? What will be the problem if I go outside that? So clearly at
Because
x equals to 0, it
inside
is not
it
continuous, sir.
exceed 1, and cos inverse because it exceeds its domain.
Hmm.
That is why these two regions are only domain of definition.
Exactly,
And
exactly. Because if x is greater than y, hmm, if x is greater than y, it cannot happen, right? So there you see, this is inside the first quadrant when I am talking about the first quad, right? And this is inside the third quad, right? So the
yes,
thing inside the root sign has to lie inside 0 and 1, na? As root over x comma 0 has to lie inside 0 and 1, right? That is, hence we are coming up with this. Okay, so let's move on to, you only have in syllabus continuity, and you have sorry, not grad, you have partial derivatives and a few problems on derivatives, right? That's all you have.
yes,
You don't have,
differentiability.
yeah, you don't have those theorems like inverse function theorem, implicit function theorem. Those are not there.
Uh,
Hmm.
Not, but there are some theorems regarding to continuity and differentiability. So I think it is sufficient or condition, not necessary condition. This some result are there.
Yeah, like if it is if it is continuous and and the partial derivatives are exist and continuous, something like that, right? Those theorems.
Yes, and the equality condition of mixed partial derivative when these
uh,
are
uh,
commute this thing.
hmm, huh. So let's do a few problems on continuity again. So we have so in the last example we observed one thing that I was mentioning in the last class, that uh, if you are approaching r theta replacing r theta in the place of x and y, so x and y are continuous functions, right? X and y are nothing but projection onto the x-axis and y-axis. From r2 to r, the function x, that is the projection onto the x-axis, and the function y, that is the projection onto the y-axis, these are continuous. But when you are replacing them, you see by r and theta, r is continuous, root over x square plus y square is of course continuous, but the theta function is not continuous. Okay, a nice problem is there. Option A. Name this function by fy. By con time in continuous. So how should we approach it? So we will look at option A later, okay? First, let's look at option, B and C. What is it? Right? So see, box y is an integer, right? Box y is an integer. Say n. So when x to the power n makes sense, tell me when x to the power n makes sense. N has to be positive, right?
Mm.
N can be 0, but n has to be, n has to be inside this. N cannot be negative 2. 1 by x square won't make sense, right? So you see, for all those y, so if y is continuous, if box y is positive. Okay, that's fine. So that was B. So not for every y, huh? Not for all y. Again for B, for all x, I mean you again fix x, then you take fx, right? This y will vary. This y will vary. So x is fixed. So take uh, fix x equals to c. Suppose. Okay. We are talking about fc. fcy. Now you see the problem. If -1, then what is your c to the power box y? C to the power
C to
0,
the
right?
-1.
Greatest integer function.
So
Okay,
it
less
is
than equals. Sorry,
-1.
sorry, sorry. -1. Sorry,
Yes.
you're right. And if y is right, so it is continuous only when c equal to 1, right? Isn't it? Hello.
Hello.
I mean, outside of that, if you take any x, I mean, the limit approaching from x, I mean, what is this? When we are trying to see this, what is this actually? So you see, this is nothing but you are approaching 0, 0, I mean, from the negative, right? And when you are looking this, you are approaching from the positive. So so you see, this thing will be continuous. I should write only if. So there is no other place of continuity, na? Okay. So you see the domain is, I mean, where it is continuous is basically this sort of a thing. I mean, a grid kind of thing. I should. X-axis, y-axis. So you see your box y has to be positive, right? So Supratim, if box y is positive, y has to be positive as well. I mean, non-negative as well.
Yes.
So it is in this domain. And then we have seen that x has to be 1. Right? So x is 1. That is this line, na?
Yes.
Not outside. So we have this domain only. Because if you go below, it is discontinuous due to y. If you go right, it is discontinuous due to x, right? Okay. Give me a moment. This throat infection is really causing a lot of trouble. So we will solve the problems on differentiability for the next two classes. For this class, let's stick to continuity. Okay, let's give another problem on continuity. I know very well that I'm not taking the class as well as I took the last one because of my health conditions. But I mean, still there are, I mean, 7 of you, I believe, there are available. So thanks to you guys. Ah, I couldn't talk till tomorrow night, so I thought about canceling the class today. But then, I mean, since I got up, I felt a little bit better. This is a weird problem. Why I say weird? Okay, after this problem, I think we can define differentiability at least.
Yes, yes.
So there's the following function. Okay. So they are saying that they have taken a set of points alpha comma beta with the following property that x to the power alpha y to the power beta by root over x square y square goes to 0 if uh, x comma y goes to 0 comma 0. Now let's name this set actually. Let's name this set S. Okay. This is the description of S. The range is the collection of points alpha comma beta in R2 such that this property holds x to the power alpha y to the power beta upon root over x square plus y square goes to 0 if x comma y approaches 0 0. S is contained in yeah. So is the problem clear? S is a set, okay? We are trying to find which one of these options, which one of these sets described in the options is a superset of S. How should I approach it? So you see, for this problem, we can do one thing to discard the options, okay? Take the path y equals to x. So then you have what? So fxy equals to x to the power alpha, y to the power beta by root over x square plus y square. It takes the form right. Right. So since fxy approaches 0 comma 0, alpha plus beta has to be greater than 1, right? That one is for sure, na? Since fxy approaches 0 comma 0, alpha 1 plus beta has to be greater than 1. So you see that will strike out a few options, right? Like this is not true. Then option A cannot be true, na? Because in option A you will get pairs alpha beta such that alpha plus beta both positive, but it is less than less than 1. Right? Again, if you take y equals to x to the power 4, if you take y equals to x to the power 4, you will come up with fxy equals to x to the power alpha plus 4 beta again by root over x square plus x to the power 8. So you see, you have x to the power alpha plus 4 beta minus 1 by, right? Since it approaches 0, again you have alpha plus 4 beta is greater than 1. Okay? So precisely you have these options. Supratim, any question? Anyone? Any question?
Yes,
Yeah.
I am saying that these two options are correct. Okay.
Hmm. But how to, I mean, and
But
but what about 2, right?
mm,
Because we have
mm,
chopped out this. We have seen
I'm
3 and 4. Yeah.
option two.
What about option 2?
I'm getting I'm getting option two. It is nothing but if we take xy by x square plus y square,
Hmm.
we have seen that is continuous. And
And
just adding power means x less than root over of x square plus y square. So as x is, I'm assuming x is positive. So x to the power alpha is equal less than x square plus y square by alpha by 2. Similarly, y to the power beta is equal to x square plus y square beta by 2. And on as they are quantity are positive, those those inequality can be multiplied to each other, get the result alpha plus beta minus 2 as a power of x square plus y square. So, so in order to be continuous, this one, it is greater than equal to 0, then alpha plus beta minus 2 greater than 0.
yeah, what are you doing here? So beta is greater than equals to 2 and is strictly greater than 2, alpha is strictly greater than 2. Yeah. Now what are you doing?
Mm. And I have reached those points only alpha plus beta equal to 2.
Acha. You are checking it for x square, y square, right? Okay,
Yes,
so what he is doing is that he is going to check it for this. Okay, and I think we have proved in the earlier class that this is continuous, na?
yes, yes.
So this is continuous. Okay, now what he is saying is that, so suppose, so he wants to write like this: x to the power alpha, y to the power beta by root over x square plus y square. He wants to write it like this: x to the power alpha minus 2, y to the power beta minus 2 multiplied with x square, right? Now he is saying that both these functions are continuous. Okay, since hence their product is also continuous, right, Supratim?
Yes, yes.
No, but this is positive because alpha is greater than 2 and beta
Mm,
is greater than 2. So this product is continuous, hence the product is also continuous. Yeah, right. So 2 is also true.
mm.
Good. Let's talk about derivative, differentiability. First, tell me, when we have a function from R to R, okay, hmm, take a point A. Differentiable. So you have f prime A. Do you realize this f prime A can be regarded as a linear function from R to R, taking this to this? Right? This is linear, right?
Yes.
So you see, at each point A, we are associating a linear map from R to R denoted by f prime A, right? That is the multiplication by f prime A, correct? The notion is exactly similar if you are going to Rm to Rn, okay? That is, at each point A, M, DFA is a linear map these are column vectors. I keep messing up with this. Right? And we have seen that if DFA exists, it is of the form yeah, go ahead, Supratim. So we are writing F as the first column will be according to F1, na? Sorry, the first row will be according to F1, right?
Yes.
Is that it? Is that correct?
Yes, it is. It is
Sorry?
a Jacobian form, I think.
Yeah. I have a very bad memory. So I keep messing up with these things, that should F1 should the first row, I mean, write it row wise or column wise, because I mean, like, but I think it is correct
It
because
is. It
it
is
is correct.
same. When we
Hmm.
taking the derivative, it is
Yeah,
same
yeah,
because
yeah, yeah, I know it is
transpose. It
same,
is
but
a
there is, I'm talking about the convention. Yeah, but x1 to xm, yeah, it is correct. So you see, okay, no, I think that should be there. Evaluating it at A, evaluating it at A. Okay, so this is your DFA. if it exists. Now you take n equal to m equal to 1 and you get back our operation, right? If you take n equal to m equal to 1, you will get f prime a. So it is the very same thing. But formally there is a definition, na? Formally there is a definition which states if Rm to Rn is diff at A, if norm, what was it? Right? This is the definition, na? And we come up with the fact that we see that this A is nothing but the Jacobian. I mean, if it exists. Okay, since we are there, let's define the partial derivatives and all that. Okay, yeah, that's good. Let's define things today, and then from the next two classes we can just do like problem sessions. So again, so what is fx or del f del x? What is it? So it is nothing but, so f is a function from R to R, say. So del f del x is what? F of x plus h comma y minus fx comma y, right? What about a directional derivative? For v equals to Rm, R2, the directional derivative so denoted by dVA. Maybe we should write, yeah, it is good. How is it denoted? I mean, how is it defined? You take f of I mean, I'm trying to write it like this. So x comma y plus tv. Okay. If is applied on the whole vector. Okay. Minus fxy by t limit t tends to 0. Right, Supratim? This is the definition. So if you just put it there, you see this is nothing but d e to f comma 0 0, and this is nothing but, no, why should I write it here? Sorry. and this is nothing but DE1F. And we have seen that this takes a particular form. What is that? So we have seen that that dvf applied at A, what is it? The dot product, right? Right, Supratim?
dg of f of a, it is the
The
direction A
directional
and
derivative, the directional derivative along V at A. This is that, na?
yes, yes.
Hmm.
Dot product of these
Hmm.
original
Yeah.
derivative and
You see, what are you
sorry,
doing actually?
total
Huh.
derivative dot that direction.
You see, what are you doing actually? So when we talk about two variable functions, suppose at this point A, we are talking about the slope, right? But if there is a function which is two variable function, so it is like a, what should I say? Like sand, right? So if you take a point here, say A, you will get here, right? But you see, instead of line, you get a plane, na? Instead of line, the slope is a plane passing through the origin, passing through this point, right? A comma fa, isn't it? A plane that is tangential to it, right? Can you visualize it?
Yes,
Just like here, it was a straight line tangential to the point A comma fa. Here it is a plane tangential to the point A comma fa, because it's like, I mean, sand is there. I mean, I'm a terrible painter, so sand is there. So it's sort of, there is a point. Think it about, so it is A comma fa. So it's like a rod. And then you are sort of trying to, what should I say? You are trying to attach a piece of a piece of maybe iron sheet in that point, so that it intersects that sand at just this point, right? Now you see, now what is TV? So TV is nothing but slope of this plane along this vector v. Okay, so this is v, right? So you see, when we say the rate of change of f, here we say rate of change of f with respect to x, right? Because it only has, I mean, one direction, I mean, a forward and a backward. But here you see the rate of change of f, rate of change of f with respect to x and y, right? So it can happen in various directions, right? So when we talk about dvf at a, we are talking basically about the rate of change of f at a along the direction v. Okay, understood?
yes.
Clear? Okay, so we will start with directional problems of directional derivative on the next class. Okay, my throat is soaring now.